Hello everyone, Dennis here. Welcome back. In this video, we are going to talk about Chapter 3, Dynamics.
This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out important updates from us.
First of all, let's discuss about Newton's laws of motion. Newton's first law states that an object will remain in a state of at rest or uniform motion in a straight line unless acted upon by an external force. So here we have two cases. The first case is this is a box which is 10 kilograms and it is at rest. So in order for it to change its state, they must have external force acting on it and it will start moving. Hence, the box has changed its state. The second case, the box is moving at constant speed in a straight line. If you want it to change the state, they must have external force acting on it so that it will change its state to at rest. Next, Newton's second law states that for an object with constant mass, the net external force or resultant force F acting on the object is equal to the product of its mass m and acceleration a. This comes to the popular formula F equals ma. The SI unit for force is kilogram meter per second square or Newton with symbol N. A force of 1 Newton exerted on an object of 1 kilogram will produce an acceleration of 1 meter per second square. Force is a vector quantity. The direction of the resultant force F on an object is the same as the direction of the acceleration A experienced by the object. Newton's third law states that for every action, there is an equal and opposite reaction. Now let's look at this object with a mass m. It applies a force of weight on the ground. At the same time, there is a reaction or normal force reacting onto the object. So there is an action and reaction pair of forces where the weight acts on the ground and reaction force acts on the body. So if a man with a weight of W equals to mg standing on the ground with 2 feet, the reaction will distribute equally on each leg. So the first one will be N equals to W over 2 and the second one will be the same, N equal W over 2. There are many types of forces. Here we'll just discuss a few. The first one is the weight W. Weight is the gravitational pull exerted on an object by the Earth. The direction is always pointing towards the center of the Earth. Hence the formula W equals mg. Next, normal force N is contact force that is perpendicular to the surface of contact when two objects are in contact to each other. Frictional force, or just friction, is a force that opposes motion between two objects in contact. The direction of friction is always parallel to the surface of contact and oppose the direction on motion of the object. Tension is pulling force exerted by a string when it is taut. Its direction is always parallel to the string. Air resistance is frictional force experienced by an object moving through air. The direction is always opposite to the direction of motion of the object. Fast-moving vehicles such as racing cars and aeroplanes are aerodynamically designed to reduce air resistance. Air will be able to flow over the vehicle more smoothly so that less energy is needed to move forward. So let's look at this diagram, which shows the aerodynamic lift. So when the vehicle moves forward, you can see that the air actually is broken into two paths, one moving up above the vehicle, another is moving below the vehicle. When the air moves above the vehicle, so it will create low pressure and high velocity for the air. If the air moves below the vehicle, it will create high pressure and low velocity. Hence, it will create a lift and lift up this vehicle. Now, let's talk about free body diagram. A free body diagram is used to solve problems involving forces. Free body diagram shows all forces acting on an object. The direction of the arrows reflect the direction of the forces. When drawn in scale, the lengths of the arrows reflect the magnitudes of the forces. Let's look at this example. Block A lies on a smooth, inclined surface and it is tied to a string as shown in the diagram below. Label all the forces acting on the block. Now the first block that you can consider will be the weight. Next, they will have a normal force N. Also, there's a tension T on the string. So these are the three forces that you can label on this free body diagram. Now, let's look at one example on free body diagram. A block of wood is pushed along a rough horizontal surface with a force of 10 Newton. It experiences friction of 4 Newton. Find its mass if its acceleration is 2 meters per second squared. To illustrate, let's look at this diagram. This is the object with a mass m. It is pushed forward with 10 newtons and the friction 4 newtons. It accelerates at 2 meters per second squared. So we know that the resultant force F will be equals to driving force minus frictional force. For this case is 10 minus 4, which will give you 6 newtons. We also know that F equals ma, hence 6 equals to m times 2, then m will be 6 over 2, which is 3 kilograms. If the resultant force acting on an object is 0, the object experiences balanced forces. If the resultant force acting on an object is not 0, then the object experiences unbalanced forces. When an object is stationary, velocity is 0 or a constant, acceleration is 0, the resultant force is 0. Let's discuss further on free body diagram. This is an object with a mass m. It is pushed forward with a driving force F1 and it experiences resistive force F2. The resistive force can be air resistance, friction, and this is the resultant force F. So if F1 is greater than F2 or the driving force is greater than the resistance force, the resultant force will be F equals F1 minus F2 or equals to ma. So if A is greater than 0, object is moving on constant acceleration. If F1 is equal to F2 or the driving force is equal to resistive force, which we actually have seen example in chapter 2, when a falling object reached terminal velocity, the resultant force F will be F1 minus F2 equals F0, and acceleration will be 0. So, at this stage, the object is at rest or moving in uniform speed, which is stated in Newton's first law. Now, if F1 is less than F2 or the driving force is less than the resistive force, again resultant force will be driving force minus resistive force or equals to ma. When a is less than 0, the object is moving at constant deceleration. Now, let's discuss an object move in vertical direction. So, this object is suspended by a string. It has a weight pointing downwards, and it is suspended by a string with a tension T. Let's assume it accelerates downwards. Hey, we know that resultant force F equals to ma. If T is greater than W, resultant force F will be equals T minus W. T minus W will equals to ma. If the box moves in upward direction, it accelerates. If the box moves in downward direction, it decelerates. The second scenario is if T is less than W, resultant force F will be equals W minus T. Hence, W minus T equals to ma. If the box moves in upward direction, it decelerates. If the box moves in downward direction, it accelerates. Next one, if T is equals W, T minus W will be equals to 0, F will be equals to 0, hence the acceleration will be 0 as well. So, the box will either at rest or in uniform speed. The box can move either upwards or downward direction when in uniform speed, which is stated in Newton's first law. Let's talk about vector diagram in forces. Let's say I have a force F1 in this direction. I have a force of F2 in this direction. I want to find the resultant force of F1 and F2 using tip-to-tail method. So I will move F2 to this position. Hence, my resultant force will be here, where F equals ma. This diagram also will tell us that the object moves in constant acceleration. Next, let's say I have a similar case with F1 in this direction, F2 in this direction, and additional force F3 in this direction. So as we have done in the previous diagram, the resultant force should be in this position, but we find that the magnitude of the resultant force is equal to the magnitude of F3, but it is in the opposite direction. Hence, the resultant force will cancel with F3. Therefore, the acceleration will be 0. Then the object is either stationary or moving in constant speed. Now, let's look at this example. A block of wood with mass 3 kg lies at rest on an inclined plane as shown in the diagram below. The normal force acting on the block is 26 newtons. Take G to be 10 meters per second squared. A. State whether the forces acting on the block are balanced or unbalanced. Explain your answer. B. Calculate the weight of the block. And C. Determine the magnitude and direction of friction acting on the block. You can pause the video and try to answer the questions your own. Okay, now look at the solution. For A, the forces acting on the block are balanced. The block is stationary. Hence, the acceleration is 0 from F equals to ma. If A is 0, then the force is 0. So for B, we know that W equals to mg. For this case, m is 3, g is 10, so 3 times 10 will get 30 newtons. For C, let F to be the friction acting on the block. The free body diagram of the forces acting on the block is shown below with the scale 1 cm to 10 newtons. You can try to draw with this scale as well. So it will looks like this, and we can move the forces by applying tip to tail method, and it will look like this. By measuring the length of the arrows in the vector diagram, friction F is found to be 15 newtons. Friction is the force experienced by two surfaces in contact with each other. An object will experience friction also when moving in fluid, or liquid or gas. Friction can prevent a stationary object from moving or slow down a moving object. It causes wear and tear and produces heat, which at the end energy loss. There are a few factors that can affect friction. The first one is the roughness of surface in contact, the magnitude of normal force, and friction is independent of the surface area of contact and temperature. Friction sometimes can be useful and sometimes is undesirable. Friction can give us firm grip. For example, car tire treads help the car to grip the roads safely. The shoe soles can prevent us from slipping down when walking. It also can be used in braking system to slow down a vehicle. It can be also used to sharpen cutting tools like knife, blades, and scissors. It also used to produce heat, for example, striking a matchstick against the side of the matchbox. However, friction can be undesirable where it produces heat and wastes energy. This reduces energy efficiency of an energy system. It also can cause wear and tear of moving parts. There are a few ways to reduce friction. First, hovercraft travels on a cushion of air to eliminate negative effect of friction. So this is the diagram of a hovercraft. You can see that it actually has a layer of cushion of air at the bottom, and there is a propeller to make it move forward. So we also use ball bearing between moving parts of bicycle wheel to reduce friction. So these are the ball bearings placed in bicycle wheels. Next, using lubricants such as oil and grease between the moving part of an engine can reduce friction as well. The shape of vehicle is designed to be streamlined. So we have discussed this previously, which will look like this. This is the shape of submarine, streamlined to allow the water to flow easily over the body. Let's look at this example. A car is moving forward on the level ground at a constant speed of 20 meters per second. The engine of the car exerts a forward force of 1000 Newton and the car experiences a total friction F. A. Find the value of F, and B. The car suffers a sudden engine problem that reduces the forward force to 500 newtons. The constant speed of the car is now reduced to 12 meters per second. Find the new value of F. C. Comparing your answer in A and B, state how F changes with speed. So you can pause the video and try to answer the question. Okay, now let's look at the solution. A. Resultant force is 0 because it stated that the car is moving at constant speed. But the resultant force is also forward force minus friction. Therefore, 1000 minus F equals 0. Therefore, the friction will be 1000 newtons. For B, resultant force F equals forward force minus friction, which is 0 equals 500 minus F, and we find the friction is 500 newtons. So, by comparing the answer from A and B, we can make a conclusion that the friction F decreases as the value of constant speed decreases. Do take note that friction is dependent on many factors such as the smoothness of the surface, the shape of the moving object, and the speed of motion. Do not assume friction stays constant unless specified.
That's all for this video. Thanks for watching. Do you have any question or doubts to ask? Feel free to write down in the comments. I would love to hear from you. Do you like this video? Please don't forget to like it and share it. Alternatively, you can also enroll this full revision course at Udemy. At Udemy, you can track your learning more effectively. Download my notes in printable PDF form. Take a summative quiz at the end of each chapter. Get your first-hand updated contents from me. Get quicker response from me, and many more. You can get all these benefits at a very affordable price. It is one-time payment, no recurring fees, no hidden costs. This saves you thousands of dollars on expensive tuition fees and revision crash courses. And most importantly, your precious time. Finally, you can do your revision anytime you like, anywhere you prefer. All is available within your fingertips. Check out the description below this video and click on the enrollment link to register the course at discounted price. Alright, until then, see you in the next video. Have a great day ahead.